Hey guys, welcome to my channel Linux King. My name is Salman Francis and today we are going to take a look at video number 2 of Kubernetes, and it's called Kubernetes the Basics. So let's start. So introduction. In this video we will see how applications are deployed in Kubernetes. I will try to explain as per my understanding. My way of explanation might differ from other professionals. And also I would like to mention that the series is known as Let's Learn DevOps. This means I'm also learning with you. So if you find any problem with my video, my training, or any information, if there's some wrong information provided to you, please do comment so I'll make sure that it's corrected. Okay, so let's start. Over here you can see a diagram I just tried to explain. Like here we can see that we have API server, the cluster store, controller manager, scheduler, kubelet, container runtime, Docker. So what is this all about? So whenever kube control, we apply with kube control, what happens? The information is sent to API server. So let me just take you to the next slide. Okay, one important thing, that kube control is the primary CLI tool to control Kubernetes cluster, and I hope there should be no confusion about it. So now kube control, whenever we apply with kube control, the information is sent to API server and the API server stores the object in cluster store. So any information whenever we apply with kube control, it's sent to API server, and API server then sends this information or stores this in the cluster store in the form of object. And then the controller manager will check the cluster store and check if there's something for it. So the thing is, like, this controller manager actually keeps on checking the cluster store, and if there's something, it will start a controller. Then this information is sent to scheduler, and what happens, the details, like once they're sent to scheduler, the scheduler will pick the node of its choice. Like in our case, we have node 1 and node 2. And then it will start and it will send the message to API server, and it will tell the API server that which node it has selected for the pod. Then kubelet basically keeps on checking for any information from API server. This kubelet keeps on checking API server for any information, like, do you have any information? Do you have any information? Do you have any information? And if, sorry about that. And when the API server has this information, it tells the kubelet that, okay, a pod is required. Kubelet will send this message to the container runtime, such as Docker in our case, and then the Docker or container runtime will pull the image for the pod and starts the pod. So this is how application is started on or deployed in Kubernetes. So again, when we apply with kubectl, the API server gets the information, and then it stores the object in cluster store. Controller manager keeps on checking the cluster store. If it has any requirement, it will then it's going to, and if it finds a requirement, it sends the details to the scheduler. Then scheduler, what will happen with the scheduler? It will tell, hey API, I'm going to use node number 1 or number 2 or node number 3 for the pod. API server will tell kubelet, like kubelet keeps on checking API server, do you need anything? Do you need anything? API server, yes, we need a pod. And kubelet will say to the container runtime, hey container runtime, like Docker in our case, hey Docker, we need a pod, go get the image. Once the image is there, the pod is started. Okay, good. Few important things to remember, like we have already went through this slide. Deployment. So now I would like to take the opportunity to explain what is deployment. Please don't forget, the deployment it represents the set of multiple identical pods with no unique identities. So this definition is taken from Google. So deployments represent a set of multiple and identical pods with no unique identities, whereas a pod is a collection of container. Just don't confuse these things. Deployment is set of multiple identical pods with no unique identities, and pod is a collection of container. Okay. A deployment runs multiple replicas of your application and automatically replaces any instances that fails. So this is very important part of Kubernetes or feature of Kubernetes, that if a deployment fails, what happens? The application, they get, like the instances get replaced automatically. And this is the best feature of Kubernetes, and that's why it's very famous. And this we will take a look in our demo. Okay, and now to create a deployment. So let's go to our terminal. And here we can see we don't have any deployment. kubectl get deployment. We don't have any. kubectl get pods. We don't have any. And kubectl get services. Sorry about that. And we can see that only Kubernetes services running, nothing else. Okay. So how we can create a deployment? It's very simple. We use kubectl create deployment. Then the deployment name, I'm going to call it HTTPD. It's my favorite web server. So, and the image I'm going to use is HTTPD. So this is how it's going to create the deployment, like kubectl create the deployment. I'm going to call it HTTPD, and the image I want is HTTPD. So now what happens to check if deployment is created? We use kubectl get deployments. And here we can see that HTTPD is running. Now to connect with deployment, I can use kubectl. Okay, you know what? First we need to check the pod, because the connection is always with the pod. kubectl get pods. Pods. So here's the pod, and I want to connect with this pod because this pod has an image of HTTPD. So to do that, kubectl exec or execute IT, it's for interactive terminal. This is the pod, and I want a bin bash shell. Okay, perfect. I'm in Apache. You can see that. Okay, I just want to make sure that Apache is running, so I'll use that Apache CTL, and here we can see that it's already running. Okay, perfect. Now to quit, we use exit, and unlike Docker, Kubernetes does not, the pod does not stops. So you can go back to this pod. Okay, over here, we are back into this pod, exit it. And this is the beauty of Kubernetes. Okay, to check again, kubectl get pods, and pod is running. Okay, now what will happen if I want to delete this pod? Let's see. So I just want to delete the pod. I'll use kubectl delete pod. And the pod name is this. So you can see it's deleted. But here, just check this pod number. Okay, the name, exact name. And let's check get pods this time. And you can see that a new pod, like just 14 seconds ago, the new pod came up. Okay, so our old pod is gone. We deleted the old pod, but the new pod has taken its place. So this is the beauty of Kubernetes. You cannot delete a pod like this. If you want to delete a pod, you need to delete the deployment. Okay, so let's delete the pod how it should be. So to do that, we use kubectl first get all, and from here you need to check what is the name of the deployment. Just copy this, kubectl delete deployment. Now let me clear the screen. If you use kubectl get pods, so now it's terminating. You can see we were pretty fast, and now it's gone. So this is how you delete the pod. Okay, but we need this. We need to create it again anyway. Let's create it. Okay, perfect. Now let's check kubectl get services. And here we can see that at the moment, only and only Kubernetes services running. Okay, now we know that we have already created our Apache image and Apache is already running there. But what if we want to expose that service? Like if I want to access service outside that container. So to do that, let's go to our next slide. So to do that, we need to expose the ports, and we can expose the ports with kubectl expose deployment httpd -port -80 -target -port is 80. So target means the original port of the server we would like to map, and this port can be anything. So let's go back and we will use that kubectl expose. Okay, before I use this command, I want to show you something. So we have this kubectl get pods. This is the command. Then for more information, we can use -o wide, and it's telling us the IP address, and this IP address is basically given to this pod by Flannel network. So yeah, so kubectl describe pod. Okay, first. So here it's describing actually everything, but I want to describe the pod HTTPD. So let me just clear the screen. We'll copy this. Kubectl describe this pod. So here you can see that the name is HTTPD and this is the name. And right now node, it's running on node number 2. App is HTTPD. IP, this is the IP which Flannel network basically gave this. And the state is running. Okay, now the thing is, like this is all the information, like more information we can get for a pod. Okay, now what happens is we need to expose the port. So we can access Apache Web from outside that container. To do that, kubectl expose deployment. I want to expose the deployment, and the name of deployment is HTTPD, and I want to expose it on port 8080, and the target port is of course 80. Okay, there's something wrong, and I think it's --target. Okay, now port is exposed, and now if we check the IP address with the services, so we have like kubectl get services, sorry. And here we can see that now HTTPD has an IP address. It's not a Flannel network like IP. So this is the IP where our container is running. This is the IP of the container. And now you can see that we have port 8080. So now if I use curl HTTP with IP address of container, and you can see on port 80 it's not working. So Control C, and if I write 8080, and it works. So this means that we have successfully accessed our Apache from outside our container. So this is how you expose the port. Just remember that target means the original port of the server we would like to map. Okay, so port 80, of course, it's the web, and where we would like to map is port 8080. In our scenario, we did this port 8080. Okay, perfect. Okay, now next thing is how we can scale a deployment, and it's very simple. So right now, if I check kubectl get deployments, so right now we have only one deployment. Okay, and if we delete this, we will have no more deployment. Okay, so now let's scale it. And to scale the deployment, it's very simple. We will use the command kubectl scale deployment, then the deployment name and the replicas of our choice. So kubectl scale deployments, name is httpd, and replicas set is equals to 3. Press enter, and perfect. Now if we get deployments, we will see we have 3 ready deployments. Up to date, available are 3. What about the pods? kubectl get pods. We have 3 pods running. And now if something, let's say if 2 pods die, 2 pods will come up. So this is the beauty of Kubernetes. Like, it's so stable. You can see that if one of our pod will die, another will come up. So let's check with kubectl get services. So Apache is still running, but it's running on the cluster, the image or the pod where we started it. Kubectl get services. So this is the IP address. So this means that these 3 deployments are the replicas of each other. Now, let's do one thing. We need to go to that pod. So I'm just going to kubectl and then get pods first. kubectl exec it Okay, this is very important actually. So let's go here and touch a file, echo something, and quit. kubectl get pods. Now I'm going to go into this pod. We just came out from this pod. Okay. Did we find sal.txt? No, we didn't. So this means that this is a replica, but the data is not saved here. So that's why we need a persistent volume. Okay. So this means if this pod gets deleted, like where the data is, we can lose data. That's why I just wanted to show you this thing. However, let me exit. And if we go back to this pod, we will have our file there. So here we have it, our file. Okay, so now exit this. So the thing is, like, this replicas can be used for, you can say, this is known as scaling. So you can use this scaling when you need more processing power. Okay, but make sure the data is on the persistent volume, so you don't lose data if you descale it. So to descale the replica set, it's very simple actually. What happens, you use the same command here, kubectl scale deployment replicas to 1. And you can say it has scaled to 1. And now if we use kubectl get pods, here we have only one running and the others have been terminated. So now we are back to 1. Okay, now let's go back to our slide. We have already scaled the deployment. We have deleted the deployment. We already know how to get the services. So we already know how to expose the ports. Okay, so the same, there was one actually question how you can deploy an Nginx. So you can do Nginx the same way we did Apache. So to do that, we use kubectl create deployment and call it Nginx, and image will be Nginx. And here you can see the deployment is created, kubectl get deployments. Okay, so now Nginx is there. Kubectl get services. Here Nginx is not exposed, so that's why it's not working. Although it's working, but we cannot access it from here. However, the same way we use exposed Apache, we can use Nginx here. So we can use deployment name is Nginx, and we would like to expose it on port 9090. And that's it. And this time if we use kubectl get services, we'll see our Nginx is there on this IP. So let's copy this, curl it, and again it's not going to work on 80. Okay, however it will work on port 9090. Perfect. So this is how you deploy Nginx. Okay, so back to our, we have already seen to delete the pods, try the below command. Okay, this we have already seen this. Kube control. Okay, these are some important commands. So kubectl cluster info. Let's take a look. Kubectl cluster dash info. I think it's here. You can see that this is kubemaster is running here, kubedns is running here, and to further debug and diagnose, this is how you use it. Kubectl cluster info dump. Okay. Next command is kubectl get nodes o wide. Kubectl get nodes dash o wide, and this is going to tell you where what kinds of nodes are running, where these nodes are running. Like here we have node number 1, node number 2, they're working fine. The image is CentOS Linux, and they will give you the internal IP addresses and something like that. Okay. Then we have to get list of system pods. We use the command kubectl get pods namespace kube system. So this is how you get the system pods. kubectl get pods dash namespace cube dash system. So these are the system pods actually. Like we have core DNS, Flannel, proxy, these are all system pods. This is our database. Okay, clear the screen. To check all the namespaces, we use kubectl get all dash namespaces, kubectl get all dash namespaces. So these are all the namespaces of virtual clusters. So kube system, these are the namespaces. Okay, default, we are using default namespace for our deployments, and kube system namespace, this is the system, you know that, the pods. Okay, so kube system namespace deployment.apps.core DNS is using kube system namespace. Okay, next we have to check the resources of kubectl API resources actually. So yes, kubectl API dash resources, and it will give you the resources like CS components and component state, basically config maps. These are the short names. These are the resources actually, like the short names, namespaces, is it using or not, what is it, the kind. So you can see it's kind, binding, component state, status, config maps, endpoint. So this is a very handy command, kubectl API resources. For example, if you want to check the component status, you use kubectl CS get CS. Okay, and here you will see that the status is healthy, and any error. So this is, you can check this for troubleshooting purpose also. Okay, now one more important command is a describe command. So kubectl, this is a detailed command actually, so it gives more details. So it describe like nodes, node 1. You can also use node instead of nodes. It's the same thing actually. So nodes or node, you can use both. So here it's telling you what kind of internal IP, the host name and stuff like that, information for the node. Describe gives you detailed information. Okay, then we have logs. This is also important. kubectl logs, and then logs about the pod. Let's check that. kubectl get pods. Here is our Nginx pod. Let's copy it. kubectl log, and this is our basically the log of that pod. We can also check what's happening with any logs generated by our HTTP or Apache container, Apache pod. And here are the pods, the logs generated by our Apache pod. Okay, and for more information we can use kubectl -h for help. Okay, what's next? We have already seen this, kubectl get pods, kubectl get services, and everything is there. Okay guys, last thing I would like to share with you is how we can save our deployment to a YAML file. And to do that, we will use the command kubectl get deployment, and the deployment I want to save is for HTTPD, and the output is YAML file. And here you can see that it has printed out in the form of YAML, like app is HTTPD, name is this, namespace is this, kind is deployment, this is the API version is extensions v1 beta 1, or we can save it with the command --httpd.yml. Okay, so cat httpd, and here is the YAML file. So thank you very much for watching, and hope to see you in next video. Please share my video with your friends and family, and do subscribe to my YouTube channel. Till next time, goodbye. See you in our next video.